The final thing that we're going to do is we're going to find the sum of a series. So given a sigma notation, we're asked to find the sum of the series from the third term to the fifth term, with each term being found using this rule, 3k squared minus 7. So what this means is I'm going to take 3 and plug it in. So 3 times 3 squared minus 7. And whatever that gives me, that'll be the first term in my series, plus I'm going to then plug in 4. So 3 times 4 squared minus 7. And then plus the last term is the fifth term. So plug in 5. 3 times 5 squared minus 7. Oops. Bracket there. And do a little bit of math here. So 9 times 3 is 27. And 27 minus 7 is 20. There's my first term. 4 squared is 16. 16 times 3 is 48. 48 minus 7 is 41. So 20 plus 41. 5 squared is 25. Times 3 is 75. Minus 7 is going to be 68. I'm going to add 68. And adding up those three terms, 20 plus 41 plus 68 is equal to 129. There would be the sum of my series. Now, the neat thing is that for those of you with calculators, you are able to plug these in. Let me show you how to do that. Again, newer calculators work the best. If you have the new operating system, this is kind of a cinch. Hit the alpha key and then F2. Again, the F function options are up here. Like we've done to find log base and other things, summation is the second option. So choose 2, and you just type stuff in. Now, the first thing is your index of summation. So pick a letter. Now, you'll notice that the A is blinking. That means that the alpha mode is selected. So whatever key I press, it's going to be a letter from here. So we had K for our index of summation. So we'll use K on the calculator right here. K equals 3 was where we started. If I hit the up arrow, I can do the upper limit, which was 5. And then I'm going to type in my rule. My rule was 3k squared minus 7. So 3k squared, hit alpha k squared minus 7. And when I hit enter, it ought to spit out 129. Same thing I got when I did that by hand. So kind of a neat way to be able to do sigma notation on your calculator for finding sums. Oh, before the calculator, there were formulas that helped us find the sums of special series, like the sum of n terms of 1. Well, obviously it's going to be 1 plus 1 plus 1 plus 1 plus 1. However many terms there are, that's what the sum is going to be. The sum of the first n positive integers, like the sum of the first 10 positive integers, 1 plus 2 plus 3 all the way up to 10, could be found by taking n times n plus 1 and dividing it by 2. Some of the squares of the first n positive integers, so like 1 plus 4 plus 9 plus 16 plus 25, etc., can be found using this formula. Now, this particular formula might be helpful to find out how many apples were in the stack we made at pick and save in a previous problem. Well, if you remember the rule from that problem, the number of apples in a given stack was equal to the number of the layer squared. So that's my rule. So to find the total number of apples in my display, I would use sigma notation. And I'm going from n equals 1 to 7 because if you remember there were 7 layers in this pyramid. The rule was n squared. So I could plug this in my calculator. That'd be just fine. Or if I were to use this particular formula, you take n times n plus 1 over 2n plus 1 all over 6. Well, n is the number of terms in the series. And again, this is the first square is the first n positive integer. So I plug in n, which is 7. 7 times 7 plus 1 times 2 times 7 plus 1 all over 6. So what that ends up being is 7 times 8 times 2 times 7 is 14 plus 1 is 15. So 7 times 8 times 15 all divided by 6. Well, you type that in your calculator or wherever it takes to do that math, you end up with 140 apples in your stack. Now, if I type that in my calculator without using this rule, it's probably going to work out even quicker. Alpha F2, summation, We'll use n. How about that? Here's n. 1 to 7. Rule being, take n and square it. 140, same thing, no problems.